All right, this is Fluid Mechanics Project 1 for Osbay's class. My name is Matthew Donahue. My partner is Noelzy. First things first, we're going to set up for our Poisel flow. Go ahead, we're going to select this, make sure it's in 2D, and we're also going to go into Design Modeler. Just make our geometry real quick by making a sketch, and then dimensioning it by the parameters. Make sure to change your units to millimeters. For this one, we are going to have a 100 length because we're going to have a 10 millimeter height. And then we're going to go ahead and clean up the sketch a little bit here. And then we're going to go ahead and generate a body, generate a surface from this. So we're going to select it and generate. And there we go. We have the geometry done. So that's done. We can now go into the meshing. First thing you're going to do is you're going to name your edges by creating name sections. After you create your sections, you're going to go to Mesh. You're going to go ahead and insert sizing mesh between these two. Apply the geometry. Switch it to dimensions. I'm going to put 2500. Change capture curvature to no. Behavior to soft, but to hard. And then you can go ahead and press generate. There you go. The first mesh is done. Now you can go ahead and deselect it, insert sizing, and pick it for the inlet and outlet. You're going to copy the conditions, but you're going to change the number of divisions to 100 for this one. And then other than that, everything else is the same. And generate and wait. All right. The last mesh we're going to put on is a face mesh. You're just going to go ahead and select here and apply your geometry and then generate. This one should load much quicker. And once that's done, go ahead and close it. Make sure you update the mesh. Once it's updated, you can go to the setup, and this is where we're going to set up the conditions for the Poisel flow. Put on double precision, press start, and give it a second. This is where you will make the boundary conditions and all the other things that make the flow that is. First things first, make sure the viscous is laminar. change your fluid to air, or make sure your air. Go here so you can change your density. For the first flow, we chose a density of 1 and a viscosity of 1 E negative 5. This gives us a Reynolds number that's around 945. Cell conditions fluid, just to confirm that we're sitting at air. Boundary conditions are inlet, it's an inlet velocity. This is where we're going to put in our velocity we want. Velocity we chose is 0.0063. Going to apply that. You're also going to go here your results, residuals. You're going to want to make this 1e negative 6. And put that for each one. It's okay. Outlet, it's going to be pressure, so it's not going to be taking in a velocity, but make sure you put on prevent first flow. Walls. You're just going to make sure they're stationary with no slip. In this case, you just double check both. This is why you name them, just that way you can make sure you're editing the correct one. Both are good. All of our conditions have been set for this. Go to our reference values. Make sure we're going from the inlet to the surface body. You'll see our numbers update to what we inputted, and then we can go ahead and initialize it. There we go, it's all done. Next, we're going to go to the run calculation part. We're going to do 200 iterations. You should usually do at the very minimum over 100. 200 to 300 is the best range. Go ahead and press calculate, and then let it calculate in load. Calculations are complete. So now we can close out of here. Just give it a second to close. After that's done, we can go ahead and click on our results portion. Here's where we're going to do our vectors, contour, and our chart to get that velocity profile. First things first, going to go here. We're going to insert indicator lines for the requirements for the midline and end line. And they're just going to be at the halfway marks for each. So in this case, it was 1500 milliliters. So we'll be going at a section of 750 milliliters. Make sure you put it to the right height as well with 100 samples. Just get a yellow little line there. And then you're going to go ahead and repeat that for the end line. In this one, you're going to put the very edge, basically as far to it as you can. And again, make it the right height. 100 samples and apply. This will be for your graphing portion later. Next, we're going to go ahead and do the contour. What you're going to do is you're going to do all domains, symmetry 1, velocity u, 110. Let's apply. Let's give you your contour. You're going to go ahead and change this. Just get out of your way. These settings, and then apply it. Next, we're going to go ahead and add vectors. Pick the same symmetry one, equally spaced, 100 points, velocity. Preferably, unless if you would like to be able to see it better, use the 3D arrow and apply it. And then as you can see, you have a contour showing the difference in velocities along with also those vectors in there, going towards our general velocity profile. Next thing we're going to do is going to go here. We're going to make a chart, title it Excel, XY line, data series. This is where you're going to choose your midline and end line. That's where you make those lines. You put your two data points. And then you're going to go here to x-axis. You're going to change it to your velocity. And then y is just going to be a y-axis. You can press apply. And there you go. You will get the Poiseuille velocity profile that you're looking for. Now we're going to go ahead, and that's the results portion done. So we can close out of this. And that's the Poiseuille flow done. Next, we're going to go ahead and we're going to start on our co-wet flow. But we're going to change some things. We're going to use some smaller dimensions. Make sure to open up Modeler, not Discovery. Same process. This time we're just going to change dimensions slightly for a smaller pipe. Units, millimeter. We're going to use 750s, and then we're going to have a 5 millimeter height for our pipe. Then we're going to go ahead and take care of those just to clean up. Zoom in, and then box select, so then we can see, we can go ahead up here, concept, surface from sketch, and apply the geometry and generate, and there we go. We've completed our dimensions. So now we can go ahead and start working on that mesh again. A second to load. There we go. Repeat the process we did in the first bit. But we're going to go ahead and we're going to name everything. Go here, and we're going to select our boundaries for our mesh again. We're going to repeat the exact same process. To the sizing mesh, geometry is going to be those two edges. We're going to go by number of divisions, 2500 again. Node to capture curvature, and behavior to hard. There we go. Once it's done, let's generate again. There you go. Meshing is done for the initial one. We'll go ahead and do our second meshing again. Take the inlet and outlet, apply our geometry, switch it to element divisions, 100. Turn off capture curvature, make sure the behavior is hard, and go ahead and press generate. All right, there we go. The mesh is completed, so now we go ahead and input our face mesh. And then go ahead and generate. That we're done with the meshing. We update our mesh. Sorry about the rain. Give a minute to update. There we go. I'm going to straighten this up and set this up for a co-wet flow. Build precision again, it's in 2D. Wait for it to load up. All right, just like before, we're going to go to viscous. We're going to make it laminar. Load it out of there. Go to materials, fluid. We have the dimensions for this already. So for this one, we're going to go with a density. It's going to still be 1. We're just going to keep density at 1 for all these instances. And our viscosity is going to change this time to 1e-3. We calculated this to come out to a Reynolds number of 1500. Go ahead, change and create, and then you can close that out. You can check again, but it's just going to be there. Then you're going to go to your inlet. You're going to change it from type of a velocity to pressure, because we're just going to go for a moving plate instead of having an inlet velocity. Just make sure you have prevent reverse flow on. Apply. And then for our walls, I messed up with the meshing. Shoot. Give me 1 second. So now we're going to go to the setup. Continue where we're going. Let me close this and then reopen it. All this part will be cut out. Just gonna make sure model is laminar. Make sure our air is the correct. Yep. Then we're gonna go boundary conditions. Our inlet's gonna be that pressure inlet. We gotta take care of that. This is a pressure outlet. Prevent reverse flow, apply, and then go to our wall. Our lower wall needs to make sure it's stationary and no slip. Upper wall, you need to make sure it is a moving wall. And for this one, we have a velocity of 2 meters per second. And with a no slip condition. You can apply that, and we can close that, and then that's all we gotta do there. Go to our reference values, go from our inlet to surface body, results, residuals. Go ahead and just copy and paste. We can go ahead and put that 1e negative 6. And then we can go and initialize it again. It's okay to ignore this warning part here. It's not going to really affect anything. It's just telling you that you did not reach that value you wanted to, but we still had data that is valuable enough to, or viable enough to actually run calculations. We're going to go to calculations, 200 iterations again, calculate. All right, the calculations are complete, so then we can go ahead and close out of this part. All right, now we got this, go to the results page, and we can actually go ahead and create our contour vectors and velocity profile for our co-wet flow. First things first, we're gonna make our lines again. Midline, which is gonna be at our center point, which is gonna be 0.375 meters or 375 millimeters. Make sure to adjust that to the correct height of 0.005. 100 samples. Next, we're gonna add our next line, which is gonna be our end line. And then it's gonna be at that 0.74999, 0.74999, 0.005, 100, apply. We have our two lines now. So now we can go ahead and do our contour. Make it symmetry 1, velocity u, 110. And we can apply that. Just like we did with the pose L, we're going to do the exact same thing. Go ahead, we're just going to change this to be horizontal and fixed. Apply just so it's out of the way. Then we're going to go ahead and add our vectors. Same thing, symmetry 1, fully spaced, 100. Symbol is going to be that 3D just so it's easier to see. We apply that, and there we go. We zoom in, you can kind of see the velocity profile change. And then we're going to go here, create our chart. then XY line. So we're going to go ahead and do our midline and end line again. And that end line. Go ahead, choose velocity U, and then put that as our y-axis again, and we should get a linear line. There we go. We're going to get our linear line, which we need file for the coet flow. So now what we're going to go ahead and do is we're just going to close out of here. And you can either choose to use the same geometry as you use for the coet or Poiseuille flow. In this case, I'm going to use same geometry and meshing as the coet. I'm just going to go here and I'm going to change some conditions of how it was set up. So that way we can mimic that hybrid flow for the third and final flow example. So once we're all done, we go here, we do everything like we did. We're going to change our fluid viscosity, keep that density at 1. We're just going to add a 0 in here for basically going down to 1e to the -4, change and create. Then we're going to go here to our cell conditions or our boundary conditions. We're going to go to our inlet. We're going to change it back to a velocity inlet. Then we're going to go ahead and we're going to apply a 0.8 velocity here. You're going to have 2 separate velocities for your inlet and your wall. The outlet pressure, you just want to make sure prevent reverse flows on. And then for our walls, we're going to keep that lower wall stationary and no slip, just like it is there. And then you go ahead and change this one to be moving, but we're going to change that down to a 0.4 meters per second. And you go ahead and apply that. And then once we've done all that, reference values, everything's done here. Residuals will be done since we're just editing this. And then you can go ahead and initialize it. There we go, it's done. And then we can run our calculation. 200 iterations again, run the calculation. All right, calculations are complete. There we go, so we can go ahead and click out of here. Go back down to our results section here. And this is where we're gonna remove the parts we had from before just so we can redo everything and update it for the correct flow. So we're gonna go ahead and complete that contour. We're gonna keep our lines in the same place, our vector and our chart. So we're gonna keep our lines, our end and midline. Go ahead, we're gonna do our contour again. All domains, symmetry 1, velocity U, 110, apply. We're just going to repeat the same process we've done for the other 2 flows. We'll see we have a different flow profile. Go ahead and add our vector in. Just same thing, symmetry 1, and then we're going to go to equally spaced, 100 symbol. You can choose whatever settings you want for the vectors. It just comes down to personal preference. This is the preference I prefer. And then we can go ahead and we can add our chart here and rename it velocity profile hybrid XY line data series. We're going to go ahead and add in our midline. And then our end line. velocity U, Y, and apply. And then we'll get that hybrid flow profile. That way we make sure we have the correct shape. We can see it goes up to that 0.4, back up towards the plate. So this is the correct profile. That is all there is for this project.